circuit with what Thevenin's voltage connected in what series with what Thevenin's resistance and what the load resistance. So given a circuit, given a big, or let's say network, you can simplify it by what? Finding a voltage VTH, which is the load voltage, the voltage that what the circuit will normally supply, and then you find the load resistance, you find the source resistance, the resistance of the total what circuit that is acting, the equivalent resistance that is acting on the what circuit. Then you draw an equivalent circuit with the Thevenin's voltage in series with the what Thevenin's resistance and what the load resistance. So let's see what we are talking about. So in all of this, you what you short your voltage source. Is it short? Yeah. Short your voltage source, open your current source, leave your dependent source. Short your voltage source, open your current source, leave your dependent source. Don't touch your dependent source at all. So let's look at question. So we have this circuit.
If now begin like this, almost audio tutorial.
You feel what the shadow is passing. And leave your dependent. This one with the
So we have to find So we have to find the Thevenin equivalent of this circuit. That's to find the VTH and the RTH. So let's start with the RTH. It's usually the easiest to get. So to find the RTH, what are we going to do? Have we drawn this circuit?
almost.
Are we true? So to find our Thevenin's resistance, what are we going to do? The instruction: open your current source, short your what? Your voltage source. So shorting this, opening this. Then we find the equivalent resistance of this. Do you know that there is a closed path here?
Yes.
The closed part here. What's the resistance here?
Sorry, 0.
Let's say infinity. So this and this are in what?
No,
Parallel.
for close part. Resistance is infinity.
Yeah.
0 now.
Zero. The resistance 0. Resistance infinity now. Current is flowing through.
No, nothing to resistance.
Resistance is 0. So at this point we have what? 0 ohms. Right? So this and this are in parallel. So what will be the equivalent resistance?
4/5.
4/5.
Yes.
Oh. So 4/5 will be in what? Will it be in series?
To be in parallel with
It will
this.
be in parallel with this. So what will be the equivalent resistance?
0.
0. So we are just leaving this part. So we just find it. So this and this will be what?
That's 2 times 3/5. That's 6/5.
Are they parallel?
Series?
Yeah, they are parallel. So we have
6/5
we have 6/5 ohms as our RT.
each. Sharp.
Do you understand this?
Yes.
There's a wire here. I didn't there was nothing here now. We'll have added it, but since there's a wire here, the resistance is 0. So if you find the equivalent resistance of everything here, you get 0. So it's like ignoring this part and paying attention to this. And if you remove this one now, this and this are in parallel. So our RTH is what? 6/5 ohms. So now we want to find our VTH. So let's return our parameters, our sources. So we have 6 amp here, right?
Yes. Then 10
And
volts.
here we have 10 volts. So we are looking for V. And V will be measured
Sorry.
across here. The voltage here. Since these two, you can see these two are in parallel. They have the same voltage. So if you can get the voltage here.
Which
you've
two?
gotten
Which
the
two? Which two?
voltage here. This place and this place.
Yes. Okay.
They are in parallel, right?
Yes.
So if we can get the voltage here, we've gotten the voltage here. Since they are in parallel, they have the same voltage.
Yes.
So this is a node, right? So V naught is like a nodal voltage. So we have to find V naught. How do we find V naught?
Using nodal analysis.
Should we use nodal analysis?
Yes.
Nodal analysis. Nodal analysis. Or can we use superposition since we have two sources? Can we superposition to be sure the answer we are
I
getting?
will not make it long. You know, I make 10 minutes.
Is it that
That's
the
easier.
superposition is long? Have we written our RT?
Yes.
So let's try to use superposition.
But it's not for now.
So shorten
For
this.
exam time too.
Shorten this now. This is 0. Right?
Yes.
So
Are you in English?
No that will work better.
you are ready. It's
10.
So that means this place is 10 now.
Yes.
This node is 10.
Yes. You can use voltage divider to get this part.
Yeah, to get 0. There is 0. So we can use voltage divider
If
to
you use voltage divider to get here, you can subtract the value from here to get here.
get. So our V1.
I'm serious. I'm not joking.
V1 will be what?
I'm serious.
10 times 1. 2 over what?
2 plus 3.
5. So V1 is what?
4.
4 volts. So if 4 volts is, we are taking 4 volts from this. Yeah. So what we passing through here is 6 volts. So that means our VTH is what? 6. VTH is 6 volts. Our
Can you
RTH is what? 6 over 5.
it's because of this one and that's why this one is not in series, right?
Eh?
This one in series. You made it in series. You made them in series.
No.
Abi? How do you get your 5?
Yeah. That voltage divider rule now is 2 plus 3 over 2 plus 3. Yeah, we more or less like making them in series. More or less like making them in series. So do we get it? Do we get it? Since they've given us the voltage here to be 10, that means this point here is 10.
Yeah.
These two are in series. These two are in series.
Which one?
So these 2 and 3 ohms are in series. So since they are in series, they will have different voltages.
Yes.
So the voltage across this, we got it to be 4 volts. So since this one 4 volts is here, and they have to add up to 10. Now this one we getting was 6 volts. So if this place is 6 volts, these two are in parallel. So whatever you have here will be the same thing you have here. So our VTH is equal to what? 6 volts straight up.
Don't need to find it out.
That's because they've given us voltage here to make it easy.
Sharp. I knew it was current that was here, uncle. Oh, you changed the voltage. This here.
If they give you current here,
Then I think his directive is correct. Yeah, it should be direct.
You use metal just add it like this.
Because
the current that flows through this place will be whatever current that is here.
take the
And then
direction.
this one to take, bring out the voltage.
I'll create time in
Like if you put it out here, call it 5 ohms, you use mesh analysis. Mesh analysis has telling us that if a resistor is staying here without a current applied to it, that current that flows here will be the same.
but you just multiply it. Do you understand? Give me some more questions. I don't know why this place question.
Please, from that
Let's some
perspective,
past question.
the empty cover from Devenis
Yes.
and the perspective.
Yes.
Which one? Is it one of 300 or one of 70 something?
Is it? Let me check that.
Or the one of 40?
Where the two? Have we copied it? So let's start solving. So we have something like this now. So now let's start applying before we do nothing down. So we have this circuit.
Okay, this is one of the past questions, Abi.
Yes.
Oh, yeah, no.
So it says what the IV law describing this network. IV law describing this network. Just the relationship between I and V. That's what they are asking for. Relationship between I and V. what's I flowing through this place? These two are in parallel. So we have V here, right? So V is flowing through here. So what will be the current flowing through this one?
That will be V all over 4.
V all over 4. We already know that the current flowing through this one is what? 2. So I total is what? V over 4 plus 2.
This doesn't matter.
Plus now.
Plus, yes.
They are just asking you to find the total current relationship with the voltage. That's IV characteristics.
Shit. And I want a question. I was even saying that
Do we get it? Do you understand it?
find another question like
They are telling you to find I.
Where's
They did not
the
give you
direction of
V.
the eye? Where's the direction of the
See
eye?
I now. See they've given
Okay,
us
it's moving
already.
like that.
So if it comes here, this other one will come here. So we already know from this
This one
reading.
plus this one. will give us
Yes,
eye.
we already know from this
Yes,
reading that 2 ohms, 2 amperes is flowing through this 5.
5, yes.
And you know that the current flowing through this one and the current flowing through this one must be equal to I.
Yes.
So since these two are in parallel, they have the same voltage. That's why I put V here. So if you have V here, the current flowing through here will be V over 4. So if V over 4 is flowing through here and 2 is flowing through here, so the total I will be V over 4 plus 2. Then you can another question. I hope you understand that one.
Yes. Are you ready?
Yeah.
We've not done nothing.
Yeah.
You've not done nothing, no, no. What are you
Save
doing this
money.
morning?
I feel the point.
Have you written?
You written it.
So let's solve this one by ourselves now.
You're right.
Me and you that one, yes.
You know when I was corporate.
Yes, I know. Yes, yeah. 4 hours time, they rest. 6 hours.
You stop writing because
Not 6, so. I'm also get like 6 hours to test. Read 3 hours, 3 hours. You see, everything has strategy. That's the plan of it. You face don't worry, anytime I want to test, I will drop the food relating to that black course. That they won't do so now. I must get everybody by saying, if a mathematician,
Can you explain again? No, that example. That one, you just know this one.
Everybody find
Come on,
V1 minus V2.
I say I equals to V over 4. I will just did those now.
Find V1 minus V2 using those method. Question dey boring. Find the value of V1 minus V2 abeg. Let's solve it from the first question. So let's see.
find the value. V1 minus
this one I know.
V into bracket 1 over 5 plus 1 over 4 plus 1. Then close the bracket, then minus V2 over 1 equals to
What is node method to start with? Node method is what? Node method is what? Is it KCL? Nodal analysis. It's just grammar.
Hey now,
Node method.
like, I know
node
you,
analysis.
I thought you were asking that what approach you use to solve it. No more, no analysis.
So
So,
find
it's
the
method narrative.
what?
Attach node.
Find B1 minus B2. That's all I look what you
No,
looking
I
for.
don't want to get
Okay, when you see movement, what is
So imagine you have like 3 minutes.
what is the one? When you see movement, what is
One minute, that's one. Abi.
B1 minus B2 is a volt now. This one is a 1 ohm.
B1 minus B2.
So imagine you have 3 minutes to solve this question. And that
That's
is
how I
solved.
exactly, but I don't know what people like that.
You have to solve it. You are still solving. Time is going.
I'm not sure I'm right though.
take time.
Take time, man. Is it not better to take
No,
time?
see, I'm thinking, current within this node there like this. Then I'll be J1 minus 4 plus V1 over 9. Plus V1 minus V2 over this one. Then add this node here, add V2 minus 1 over this one, V2 over this one, then minus
Write it, because I don't understand what you're saying. Write it down. Let me see.
Minus. No, not equal to 0. I don't think V2 is equal to 0.
It's equals to this far. That one is equals to that for cheap. I might be paying, I write it for I can't see.
Yeah, 15. Like this one, can you understand? Like this one explain this one. Come on. Think in terms here. Good.
Let me solve it now with my paper.
This one.
When you give me pen, give me your pen.
This one is living. This one is living.
I saw this. Two times you go see one back. This one. Really?
You can take it.
You can continue.